Hi, I would like to share my results about the experiments that I did about optimizing multiple thermoelectric units for maximum cooling performance. My goal for this experiment was optimizing TEC size, stacking to achieve lower temperatures, voltage and current adjustments, minimizing wasted heat, maximizing cooling efficiency, otherwise known as COP, and a compact system. Thermoelectric modules uses the Peltier effect to create a heat flux at the junction of two different types of materials. It's basically a solid-state heat pump. The pros are small, relatively inexpensive, and no moving parts. Cons, however, are poor power efficiency and low COP. Experiments were done in a 23 to 25 degrees Celsius room. Equipment used: STM3055 with the RTD-PT100 temperature sensor, IT6302 3-channel power supply, and an additional DPS5015 power supply. I posted the experiments on Hackaday, so I will briefly go through the pictures. As you can see, I got better results, the first being 1.8, -6, -7, -13, -23, and lastly -27. Hi, in this presentation I will talk about my project, the miniature fridge. These are the pictures that I took from the 3D modeling program, and this is with all the components. Testing the TEC stack with the buck converters set to its desired voltage and current. As you can see, I got a temperature reading on the surface of the TEC of -26 degrees C. And for the electronics, I first wired them to a breadboard, and then using wires, I directly soldered them to the actual Arduino. For the assembly, it's straightforward. I screwed in the two buck converters needed for the 4040 TEC and the 3030 TEC. I mounted the fan to the heatsink and connected all the cables and plugs and placed the heatsink where it's supposed to be. This is another picture of me assembling. And at this point everything was installed, but I had some problems on the OLED display turning off when I reached about 2 degrees. It was just shutting off. So I was troubleshooting at this moment, and I found out that the circulating fan inside the chamber was causing the problem. As temperature goes down, the actual fan increased in current because in a resistive load, if you lower the temperature, it would lower the resistance, so the current flowing would be higher. The fan was directly connected to the Arduino 5-volt rail, and it was pulling too much power so that the Arduino was keep resetting itself. So I fixed that with a 12-volt fan connected directly from the 12-volt power coming from the back. This is the finished fridge. As you can see, after about 5 or 10 minutes, I could get a chamber temperature of -6.66 degrees Celsius, and the hot side was 27.02 degrees Celsius. I filled a miniature vase with some water and placed it in the freezer. After about 15 to 20 minutes, it froze like you see in the picture.